What's up, guys, and welcome back to this tutorial series by Avidz in C++. So this part is part 2, and if you haven't checked out part 1, check it out first because it's some basics about Visual Studio and stuff, and the IDE that we're using throughout this series. So check that out first. And this part is called variables, and we're gonna go through some more stuff than variables, but I named it this just because simplicity. So let's start. What will we do in this episode? So we will go through variables and data types. We will go through input and output. So it's input and output from the program and to the program. So input to the program from the keyboard and output to the screen. And that's just the basics of input and output, but it's just what we need in this course. So strings, because strings is not a fundamental data type. And I'm gonna go through later what a fundamental data type is. But yeah. So type conversion, or changing the type of a variable or such, like from an integer to a float and from a double to an integer and so. It's kind of important sometimes because the program can crash if it's not working properly. We're also gonna go through increment and decrement, and it's just a small part, but it's important to know. It's increasing a number or decreasing a number. So yeah, data types then. So there's 20 fundamental data types, and I think it's only 4 that's really important. And it's the integer, which is numbers without decimals. So it's 1 and 2 and 3, but not 1.5 and not 2.5 or 1.3 or 4.2 or something like that. It's just 1, 2, 3, 4, and minus 1 and minus 2 and minus 3. So the int, float, double, and bool is the most important, I think, for now. The 20 fundamental data types there is stuff like long int or long int, which is only a bigger version of the int because the int is limited to a certain size, but with a long int it's bigger, and a long int is even bigger. So but that's not important right now because we won't be using that large numbers, and it's not very hard to, or it's not that hard to look up on the internet what a long int is or a long int is. So the most important thing is to understand the basics of this. So yeah. So an integer, I said, was whole numbers. We also have a float, which is all the numbers, so 0.1, 0.2, 0.3, and so on. And if you set float equal to 1, it's gonna be 1.0. Same with double. Double and float are almost equal. They're used in the same way anyway. So and we also have the bool or boolean. It contains a boolean value, true or false. So it's also very important to have when you do loops and stuff like that. So yeah. So strings, or the string data type, is not a fundamental data type. It's still a data type though. It's a data type made by someone someone after the C++ was made. So it's not built into the language. So you will have to include the string library, and a string variable is just an array of chars. So a char is also a data type. It's a fundamental data type. It's just one character, so it's A or B or C and so forth. I never used chars, so for now it's not important to go through. We're gonna go through it later, maybe, but not right now. So variables. A variable can contain data of some type. It doesn't necessarily have to, but it wouldn't be useful if it didn't. So yeah, it must have a data type, so an integer or double or float or something like that. And a variable can be changed, so that's the fun part about it, or the good part about it. It's very useful when you write long programs and you need to have a variable that change over the time. So the table here is a visualization of the random access memory, and if we make a variable, the variable name will point to an address. So an address in the random access memory. So let's say we have a variable that's called, it's an int, an integer variable with the name number1, and it's equal to 45, or it contains 45. So then the number 1 points to the address 510 in this table, and the address 510 contains 45. So it doesn't have to be 510. This is just random. I just made it like this for you to understand, but so this is different for all the computers. But this is how it works, or just an overview of how it works. So fast input and output. When we do input and output, we use cout and cin operators, and this stands for console out and console in operators. So cout is when you print something on the screen or send something out from the program, and cin is when you take in information from the user. So cin is the keyboard or the mouse or something like that. Cin is actually the keyboard for now. So we use these double arrow operators, as I call them, and I will show later how we use them. It's not hard, and it's very logical how to use them. And we have to include the IOStream library. So just like string, it's a library. It's not built into the programming language, and we have to include a library. So well, type change then, or type conversion. There are two types of type conversions, and it's implicit and explicit. So an implicit type change is when you have an integer a that's equal to 45, and you make a double b, a double with the name b, that's equal to 28.63, for example. And then you set a equal to b. So then you copy the value of b to a, but also the type, the data type of b to a. So a will become a double with the value of b. I'm gonna show that later on also, but so yeah, the explicit also is when you write the data type that you want to change something to in front of it. Yeah, so usage, it's useful because sometimes when you split something in two, or you do mathematical calculations, if the data type is wrong for the output or the answer of the calculation or something like that, and the program will sometimes give a fault or an error, and you will have to go through it. So it's good to know how to do type conversions. Increment and decrement, it's the plus plus and minus minus operator, and plus plus is used to increment them. So let's say we have 45, we do plus plus, it increments it by 1, and the same with the minus minus, it decrements with 1. So yeah, but we're gonna go through this in Visual Studio, so yeah, let's go to Visual Studio. So yeah, we're in Visual Studio again, and I made a project now with the main C++ file, and if you don't know how to do it, check part number 1 of this tutorial series, and you will see how to do it. So, well, we talked about we need a main function. So let's make the main function, and it will return 0. And that's important because return 0 means that the excavation of the program, or when we run the program, it returns 0, and 0 means okay, it means no errors. So yeah, just for starters, a quick tip is that 2 slash signs makes a comment. So this is a comment, and I'm gonna make a comment that says streaming. So yeah, but before that we need to go through the include, and I think we included the last time in the last episode, but we'll go through it again. So it's a hashtag sign, and then include. So include is keyword, and then when we're gonna do input and output, we need to include the IO stream library, as I said before. We also gonna use strings, so we can include the string library like this. Like that. So just to test and see, we can make a cout that is like this, and it's 45 times 2, and then endl. Endl means end line, So that means that it will go to a new line. So yeah, so we can build this, we compile it, build it, and then start without debugging. And well, yeah, 90. So that's right, it's 45 times 2. And this std, haha, it's a fun keyword. Std stands for standard, and it's the namespace. So we can write like this up here outside the main function, and then we won't have to use this standard namespaces. So yeah, so that's streaming for cout. We can leave that there. So you can always make like new couts like this if you want to make 2 new lines. So yeah, so we go into variables. First we said we had an integer, which you write like int, and then the name can be number 1, for example, and it can be equal to, or it can contain 10. Then we had float. A float is f number, we can say, and it's equal to 12.4, like that. Then we had double, and it's double d number equals, let's say 43.3, or we can just set 43 just for fun. So, and then we had the boolean, and it's bool bool can be, for example, equals true. So these are the 4 important data types. Yeah, and we also have a string, but it's not fundamental. So string, and you can see that by the color of it. So the not fundamental data types becomes green when you write them out. So string, say name equals my name, Michael. That. So let's say we want to write all these out. So cout number 1, and then we write out f number and a new line, and then we write out d number, new line, can be, new line, and last but not least we write out name and line. So this is the way you write out variables. You just write them, and here we use this arrow operator. I see this double arrow operator, as we talked about before, and so it means console out means out to the screen, and these two arrows means that the variable goes in the direction of the arrows. We can say that for simplicity. So number 1 goes to cout, and then an end line, and then f number goes to cout, and then another line, or we make a new line, and then d number goes to cout, and then we make a new line. Can be goes to cout, new line, name goes to cout, and then new line. So yeah, if we build this now, and then we debug this, we're gonna see it like this. So it's 45 times 2, and it's 90, and then it's a new line, and it's a new line, and it's a new line. So then we wrote out number 1, which is 10. We wrote out the float, which is 12.4. We wrote out the double, which is 43, and we wrote out the bool or boolean value, which is true, and true is 1. So false is 0, and true is all values that are not 0. Often it's 1, but it can be another number as well. So, and last we wrote out my name, so Michael. So that works like a charm. And if we want to use cin, we write cin instead, and we write this backwards double arrows to, let's say, name. And then we write cout name again. And what this will do is, after we wrote this out, it's gonna ask for the user to write something on the keyboard, and then what the user writes in gets put into the name variable. So that's what I talked about before. A variable can be changed all along the program. So this is good. Maybe I change my name. So let's build this. So after Michael here, it's this blinking thing. So here we write Batman, and then we print out Batman, or we print out the name. So Batman gets put into name, and then we write out the name, which is Batman. Hope you understand so far. So yeah, we can comment all this out for now. And we're gonna go through, or this can be open. So the data types. So we're gonna go through type change, and implicit and explicit type change. So implicit is here. So implicit type change, as I said before, is if you have like a int a equals to 10. You see, an integer can't hold decimal, so it can't be 45, because then it will only remove the 45 and be 10. So int a equals 10. We have a double b equals 10.0. something like that, or maybe we can have it 26.7 or something like that. And then we set a equals to b. So as I said, if we would write a equal to 10.68 or something like that, it would only be 10 anyways, because it would remove the decimals. But what happens now when we set a equals to b? So a, which is 10, or the a variable is equals to 26.7. But a is an integer, so it wouldn't be able to hold 26.7. It would only be able to hold 26. But if we write this like this, what happens? So actually, this is what happens. So it removes the 7, the 0.7, and it becomes 26. So yeah, this is the implicit type change. We took the double b and remade it into a integer. But we can do like this also. So we can take see here, we can write int, and then we write b. We can write like this, int, then b, and then end line. And what happens now is that it will do exactly the same thing. So it will make the b an int for now, but then if we write it out, here, it will still be a double, so it won't change more than when it writes it out, when it's used here. So it won't change the data type of the b variable forever, just when it uses it. So yeah, and that's this is explicit type conversion. So well, yeah, say if we have an integer that's 5, integer a equals, can't do that, integer c, yeah, also if I write integer a here now, equals 5, it won't work because we'll already have an integer a, so it would be a double, and it would be a you know, we can't make it twice, so we have to name this something else. Divide, we can name it. And then we have a integer that's a divide with, we can call it, so it's 2. And then we do this cout divide, it was divide with, and see what happens. So it's only gonna output 2, and that's because it's 2 ints, and integers can hold decimals, as I said before, and therefore it removes the 0.5, which 5 divided by 2 is 2.5, so it removes the 0.5 and the 2 is left. So to fix this, we probably have to make this. We do an explicit type change of the first number that we put in. So if we make this now, or not an int, I'm so sorry, double, we can make it. So there we make it a double, and there you see that it's 2.5. So that's because we made a type conversion on the int into a double, and then the double of 5.0 is divided by 2, which is 2.5. So then it outputs a double. So yeah, it's an automatic conversion here in this case. So it's double, we make this double, and it also makes the output a double. Yeah. So I think that's it for now. There's a lot of ways to, learn this and go around it, and but it's only useful if it's not working, kind of. I've never found any use for it if I'm not actually using the number for something mathematical or something like that. So yeah, the last thing that we're gonna go through is increment and decrement. And as I said before, it's a really easy part, so it's not really hard to learn or understand at all. It's like this. We can do an int that's called inc for increment, so it's equal to 4. We also do an int that's called des or decrement, that's equal 6, say. So then we print out the inc and line, and this, and then end line. So I think we're gonna take this and just comment it out. So yeah, so then we do inc plus plus for increment, and this minus minus for decrement, and then we do the same print out again afterwards to see if it worked. So see here, we have the increment variable, it's 4, it prints out 4, and we have the decrement variable, it's 6, prints out 6. And then we increment 4, so it becomes 5, and we decrement 6, which becomes 5. So 5 and 5. So that's not hard to learn at all. Yeah, so I think that's it for now. We're gonna go through more things about strings later on, with how to use them, how to use the functions made for strings and stuff like that. But I think we're gonna go through arrays first, because it's more logical to understand and think about it. that way. So we wait with the strings for now. So at least you know how it works, and that you can write out strings like here, or make string variables just the same as other variables, but it's you see this is green instead of blue in my case. Like the fundamental data types are blue in my case, and the non-fundamental data types are green. So yeah, this is still basic, so if you feel that this is too easy for you, just skip ahead a few tutorials. And if you watch it like now when I put it out, I'm really sorry. I'm trying my best to keep up the speed of the tutorials. So if the next tutorial isn't out, just wait, or write a comment, or send me a message or something like that, and I will try to answer and you know. So thanks for watching, guys. Don't forget to like and subscribe down below. If you have any questions, don't hesitate to contact me, either through message or mail, or in the comment section down below. But I think that's all for today. So until the next time, peace out.